Hey, welcome! Have you ever wondered how you can shuffle data around, with maximum efficiency? Well, today, we're going to tackle a classic computer science puzzle that seems really tricky at first, but trust me, it has a surprisingly elegant solution.
Okay, let's just dive right in. Imagine you've got a list, right? An array of numbers, and you need to shift the beginning of it to the end. But here's the real challenge. You are not allowed to just make a copy. You have to do it all inside that original list. So how on earth is that even possible?
So first things first, let's get on the same page about what we're actually trying to do here. We're talking about something called array rotation.
I want you to think of it like a little conveyor belt. The items that fall off the front end just kind of reappear at the back, and they're in the exact same order. So we're not just scrambling the elements, we're shifting them as one single connected block.
Let's make this super concrete. If we start with the numbers 1 through 5 and we say rotate them by 2 spots, what happens is the 1 and 2 move from the front all the way to the back. Our final destination, our goal, is an array that starts with 3.
So, moving numbers around, that's one thing. But now, let's add the little constraint that makes this a truly great puzzle. We have to do it in place.
Look, the easy way out would be to just create a second, totally empty array and just copy the numbers into their correct new spots. It's simple, yeah? But it uses up extra computer memory. The in-place challenge, on the other hand, forces us to be clever. We have to modify the original array without any outside help. This whole thing is about efficiency.
And this isn't just some, academic exercise. This exact phrase is a super common requirement in software development interviews and coding challenges. It's really a test of whether you can think efficiently about how you use your resources.
All right, so how in the world do we solve it? Well, it turns out there's this beautiful 3-step algorithm. Let's pull back the curtain on this little secret.
The key to this entire puzzle is a single, simple action, reversing the order of elements. Now, I know what you're thinking. That sounds strange, right? How does reversing things help us rotate them? Just stick with me here. It's all about to make perfect sense.
Here they are, the 3 magic steps. First, we reverse just the block of elements we want to move. Second, we reverse the rest of the array. And then finally, we reverse the whole thing. I know it seems almost random, but this is pure, beautiful logic.
All right, it is time for the big aha moment. Let's actually walk through this algorithm with our example and just watch the transformation happen step by step.
Okay, so here's our setup again. The array is 1, 2, 3, 4, 5, and we need to rotate it by 2 positions. That means the part we're moving is that 1, 2 at the front.
Step 1, we're going to reverse just that first part, the 1, 2. It's a simple swap.
So after that first step, our array now looks like this. The array 1, 2 has become 2, 1. And at this point, it definitely doesn't look like we're getting any closer to our solution, does it?
Okay, next up, we ignore the part we just touched and we reverse the remainder of the array, which is 3, 4, 5.
And now it looks even more jumbled. We've got 2, 1, followed by 5, 4, 3. Honestly, this is the moment where you might think the algorithm is totally broken. But you gotta trust the process. The magic is all in the final step.
And now for the grand finale. We take this whole jumbled up array from the very beginning to the very end, and we reverse it.
And just like that, 3, 4, 5, 1, 2. It is the exact result we wanted. The 3 reversals have perfectly rotated our array. Pretty cool, huh?
But why does this work? It feels like a magic trick, I get it, but there's some really solid logic hiding behind it. So let's break it down.
Okay, think of our array as 2 blocks. Block A is the part we want to move, so 1, 2. And block B is the rest, 3, 4, 5. Our goal is to get to B followed by A. Now our first 2 steps created a reversed A next to a reversed B. When we do that final big reversal on the whole shebang, 2 things happen at once. First, it flips the order of the blocks themselves, putting the reversed B block before the reversed A block. And second, it also unreverses the elements inside each block, which gives us our perfect BA structure. It's so clever. And remember the best part? The number of extra arrays we needed to store our data to pull this off was a big fat 0. Absolutely none. It's a masterpiece of in-place efficiency.
This whole thing leaves us with a pretty fascinating thought. This problem looks really complicated, but the solution was just based on a simple, repeated action. It really makes you wonder,
What other complex problems out there are just waiting for a simple, elegant trick to come along and solve them? Thanks for joining me on this one.